Hello, this is Dr. Divya Pradhan, and today we are going to talk about acids and bases. So, what are acids? Acidic solution contains very high hydrogen concentrations. So, these are chemical compounds that release hydrogen ions when dissociated in water. So, in aqueous solution, obviously, acids are going to contain, or they have, what is called a replaceable hydrogen ion. A charged particle is an ion, right? If I just write this, it's an atom. If I write this, molecule of hydrogen, atom of hydrogen, ion of hydrogen, okay? So a common example, of course, is hydrochloric acid. Hydrochloric acid breaks up in aqueous, in water, of course. It'll break up into hydrogen ions and chloride ions, right? Now, on the other hand, a basic solution or a base will have low hydrogen concentration but a very high hydroxide concentration. So, bases are chemical compounds that release hydrogen ions, or what happens is they will take up hydrogen ions. So, very common base is sodium hydroxide, and in aqueous solution in water it is going to break up into sodium ions and hydroxide ions. Alright, now how do you measure the acidity or the basicity? Another word is alkalinity of a solution. So what we do is we use it on a pH scale. So here the scale goes all the way from 0 to 14. If a pH scale is below 7, then it's acidic, meaning to say that the hydrogen ions are way higher than the hydroxide ions. If the pH is above 7, then it's basic. That means the hydroxide ions are way higher than hydrogen ions. But if the pH is neutral, that means the hydrogen ions are equal to the hydroxide ions. All right. So water is close to 7, not quite, but close to 7. All right, or it's supposed to be close to 7. Here is a chart and showing you the usual compounds that we are familiar with, where they lie on the pH scale. So for example, lemon juice is close to 2, but watch, soda is very close to 3. This is why I do not like, one of the reasons why I do not appreciate or do not encourage soda drinking. Milk is close to neutral, a little bit lower than neutral, a little bit lower than 7, but close to neutral. And that is why back home, if you have acidity in your stomach, they advise you to drink cold milk. Of course, then you have baking soda, very much at 9, and finally sodium hydroxide you have at 14. You can also read the other compounds that are available or that you are familiar with. All right. But more than anything important for us today, especially in biology, are buffers. So what's a buffer? Buffer is a chemical compound. So basically, it is a salt of a weak acid as well as a base or a conjugate base. So here, it's a chemical compound, and this will help to keep the pH within normal limits. This is especially important for biology, because in biology we come across the word what? Homeostasis. And what is that? Homeo means constant. Stasis means state. So you are going to maintain, all living things maintain a constant internal environment, okay, a stable internal environment. So for example, the pH of blood ranges all the way from 7.45, 7.35 to 7.45 is the range. How does blood maintain this? Well, blood has a very important buffer. What is that? The bicarbonate ions, okay? And these bicarbonate ions will help stabilize the pH. Well, how does it do that? All right. So if there is a huge influx of hydrogen ions, then the hydrogen ions bind with the bicarbonate to give you carbonic acid. All right. So here so it acts as a sink, right? Hydroxide ions, if they are added, they will bind to the H2CO3, and now the reaction will go other way, and you'll add more bicarbonate ions to your what? To your blood. Either way, the pH is not going to change. pH will change only if there is H added or OH added. In this case, the pH is going to go down. In this case, the pH is going to go up. But because of the buffer, look, it's going to neutralize this, and therefore you are not going to have any or very little change in the pH. So a stable level of 7.35 to 7.45 can be maintained. If it goes beyond this, you know very well that the blood is going to, all the proteins are going to denature, and therefore the blood will lose its function. So yes, with this we come to the end of our presentation. I thank you for your time and attention, and if there are questions or concerns, then please stop by my office.